Hi, this is Maria Gevorkyan, Database Systems Assignment 4. First exercise. For each of the given relations and their respective functional dependencies, find the minimal cover. Explain in detail all the three steps that you are going to use to find the minimal cover. Find all the candidate keys of the relation R by determining their closures of attributes. So, right here. Okay. The three steps are: first, split. All fundamental dependencies must have one attribute on their right side. Second, remove extraneous attributes. Remove trivial redundant functional dependencies. First relation is R, A, B, C, D, E, F, and we have these functional dependencies. First step, split. The only thing we have to split here is this A goes to BC. We split it here like this. Second, remove extraneous attributes. The only extraneous attribute I found here is this B, because A goes to C and C goes to D. The A goes to D automatically, so we don't need the B. And remove trivial redundant functional dependencies. Trivial redundant is when we remove the D, we have A goes to D, which is implied from A goes to C and C goes to D. So it's a trivial redundant functional dependency, so we don't need it. We remove that. Everything else is fine. So we have the minimal and final form here. In the final form, I just connected these two because it's easier to find the candidate keys right like that. But this is the minimal cover. Okay. So the only attribute that isn't on the right hand side is A. So first we try A's closure. A's closure, A goes to A goes to B, A goes to C, C goes to D, D goes to E. We have A and we got E already, so AE goes to F. And that's it. We got the R, so it's the candidate key. No need to check for other candidate keys because we took attributes that aren't on the right hand side and got the candidate key. And the only attribute that wasn't on the right hand side was A. So the prime is A. The exercise didn't want me to find the prime, but I wrote it anyway. Second relation, W, X, Y, Z. Z goes to W, Y goes to X, Z. By first step we split that up, and WX goes to Y. We open the second row, we get this. This is the final form. This is the final minimal cover, so there's nothing else to change. All attributes exist on the right hand side. Try all one by one to find the candidate keys. So we find the closure of W, X, Y, and Z. None of them are candidate keys as we see. We can see that Y gives Y, X, Z, F, all but W. So we first try W and Y, get that it's a candidate key. Then the only next one with W that gives, with Y that gives W is Z. We can try that too, and that gives candidate key as well. When we try to take X with candidate key, we either take it with WY or YZ, so it's not a candidate key, not a minimal candidate key. So these two are the only candidate keys we're looking for, and the primes are W, Y, and Z. Next exercise. Given the following musical group relation with the functional dependencies, this is the relation, convert it to 3NF, explain all your steps in detail, show how you find the candidate key, underline the primary keys of the decomposited relation. Musical group, name, artist name, genre, date founded, and date joined. And functional dependencies are group name to genre and date founded. This is by first step we split. Group name and artist name goes to date joined. So this is the final form. We split that up. Group name to genre, group name to date founded, group name and artist name to date joined. Nothing else to change. This is the final minimal cover. So through to the relation is 3NF if RR is in 2NF. We already don't know what that means. There are no transitive dependencies for NP, not non-prime attributes. E, no non-prime goes to non-prime. This already exists in 2NF because 2NF says non-prime or prime combination doesn't go to non-prime. So this already exists in 2NF. So if it's 2NF, it's probably 3NF too. Oh, okay. So we go through our Finimo cover form to see if it's a 3NF. Group name is not fully prime because group name with, where did I write the candidate key? Oh, here. Group name and artist name together. Uh, I chose these two because those are the only ones that aren't on the right hand side. Give the whole musical group. Group name gives genre, name gives group name gives date founded, artist name and group name together gives date joined and artist name from artist name. So we got the whole musical group, so it's the candidate key. So prime are group name and artist name. So group name by itself is not prime, artist name by itself is not prime. So the first two rows are um, not 3NF form. The third row, two together are prime, and date joint is not prime, it's okay. So the first two we need to change. How we do that? We take the left and right hand side and take the left hand side as uh, PK, primary key. The relation 1, relation 2, the first two rows, and third row we just take the candidate key by itself and take the whole thing as candidate key. Here I explain this under the exercise. Exercise 3. Given the following movie cast relation with the functional dependencies converted to BCNF by using BCNF decomposition, underline the primary keys of the decomposed relation. Movie cast, movie title, actor ID, actor first name, last name, role, release year, date joined. This is our R, and the functional dependencies are the following. Movie title goes to release year, movie title, actor ID, date joined, actor ID and role to movie title, actor ID to actor first name, last name. The last one we open to actor, split to actor first name, last name. And this is our minimal cover form. The longer I look at it, I looked at it for 10-15 minutes. This is the final form. So actor ID role aren't on the right hand side, so by their closure, trying to find the candidate key. Actor ID and role give us actor ID, role. Actor ID and role gives us movie title. Movie title gives us release year, movie title with actor ID, which we took. Date joined, and actor ID alone also gives actor first name and last name. We got the whole movie cast, which is so it's the candidate key. And our primes are actor ID and role here. Now let's try to see if it's uh, BCNF or not. A relation is BCNF if for any non-trivial functional dependency A goes to B, from functional dependency set A is super key for R. Decomposition will be A and B and R minus the A. So like if it goes A to B, we decomposited A to B underline the A, and on another decomposition will be everything except B. Let's see if it's right form. Movie title is not super key, release year is not prime. This is wrong. Second one, not super key, movie title is not super key, actor ID alone is not super key. So this is wrong as well because date joint is not prime. movie title, not prime, actor ID, and role are super keys. So this row only is correct. The other two, actor first name and last name, are not prime. Actor ID alone is not super key, so those two are wrong as well. So here is my relation tree. This is the whole R. Firstly, let me do this so we can see that as well. Firstly, we do the first row. We take movie title and release here together. Movie title is left hand side. We underline it as primary key. Relate that will be R1. R2 will be everything but release here. Now we see that movie title, actor ID, date joined. The second wrong row is all in R2. So the next operation we'll do on R2. Movie title and actor ID left hand side will take as primary key R21, and date joined will be the other part of R21. Everything else except date joined will be R22. The next row that is wrong is actor ID to actor first name. Both are in R22, so we take actor ID, actor first name as R221, actor ID as PK. Everything else except after actor first name will be R22. And the last wrong row, actor ID to actor last name, we take that out from R22. We'll get the R221, actor ID left hand side will be primary key, R222 will be movie title, actor ID, and role. Usually when we do this relation tree to find BCNF, we get the CK at the end. Here we didn't. Of course, if we take out the right row, actor ID, role, and movie title from here, we'll get the CK, but it is not needed because actor ID, role to movie title is actually right. So all the left parts of our tree and the last right part is our final relations. R1, R21, R221, R2221, and R2222 is our final relations that will give BCNF1. This is the whole homework. Thank you for watching.